Hello everyone, welcome back to our channel. So today we are going to see the second part of this topic, that is moment of a force about a line. In the previous video we have discussed how to find the moment of a force about a point, but today we'll see how to find the moment of a force about a line. So to find a moment of any force, first we should find out the vector form of that force. So vector form can be calculated in this form like fxi plus fyj plus fzk. Now this is the given line whose initial point is C, coordinates are x3, y3, zt, and the next point on this line is D, whose coordinates are x4, y4 and z4. So now connect this point C with the initial point of the force. I will repeat, connect the initial point of this line with the initial point of the force. So connect it, find out the position vector for this line. Now the position vector can be calculated in the format rxi plus ryj plus rzk. After this, take the cross product of the position vector and the force vector. So moment of the force F about point C is equal to position vector into the given force vector. So if you observe step 1, step 2 and step 3, and if you have watched our previous video, you will come to know that the procedure is similar like taking a moment of a force about a point. So first 3 points are similar to that one. After that, find out the unit vector for this line CD. The unit vector can be calculated in the format exi plus eyj plus ezk. Don't get confused. If you don't know anything about the vector, I will give you step by step way to find out the vectors for every cases. Okay, so watch this video till the end to understand the simple concept of the moment. Step 5, take the dot product of the moment and the unit vector, and finally multiply this magnitude with the unit vector to get the final moment of the force about the line. So this is a 6 steps process. In the first step we'll find out the force vector, in the second step we'll find out the position vector, in third step we'll take the cross product of the position vector and force vector, in the next step we'll find out the unit vector for this line, then we'll multiply the moment with the unit vector, and then we'll find out the product of this magnitude into the unit vector. So this will give you the final answer for this question. So we'll start with the question. A force of magnitude 10 kN acts at a point P 235 meter, has its line of action passing through point Q 10 minus 3 4 meter. Calculate the moment of this force is about an axis passing through ST, where S is the point 1 minus 10 3 meter and T is 5 minus 8 8 meter. The magnitude of force is given 10 kilonewton. Starting point of the force P is given, then the end point of this force is Q. So 2 points are given for the force. For the line, the initial point is S and final point is T. So I'll mark the initial point by I and final point by F. Same here for the force, initial and final point. Now we'll start with finding the force vector. Now the final point for the force is Q, so write it here, and the initial point for the force is P. The magnitude of the force is given 10 kN. We'll write down the coordinates of for point Q. Simply copy the points from the given question. 10 minus 3 4. For point P it is 2, 3 and 5. Now subtract the second row from the first row, that is 10 minus 2. So x2 minus x1 is equal to 10 minus 2, it is equal to 8. Then minus 3 minus 3, so it is minus 6. So y2 minus y6 is equal to minus 6. 4 minus 5, so it is minus 1. So z2 minus z1 is equal to minus 1. Now find out the square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So square all the terms and add them. So here we get the answer 10.050. After this we can find out the components of fx, fy, fz. So fx is equal to 10 into x2 minus x1, that is 8, divided by 10.050. So here the equation is 10 into 8 divided by 10.050. So the answer is 7.96. To calculate the value of Fy, multiply this magnitude 10 into y2 minus y1, that is minus 6, divided by 10.050. The answer is minus 5.97. To get the value of Fz, multiply the 10 with minus 1 divided by 10.050. The answer is minus 0.995. So in this way, you can calculate the value of Fx, Fy, Fz using this single table. So now we'll represent this force into vector form as 7.96 I minus 5.97 J minus 0.995 K. So this is the vector form of the given force. Now we'll find out the position vector. For that, we know that this is the given force P and Q points. This is the given line S and T. So as we have discussed, connect the initial point of this line with the initial point of the force. So connect S and P. Here the initial point for this position vector is S and final point is P. So P is written first here. So P, coordinates of P are 2, 3, 5. So 2, 3, 5. Coordinates of point S are, here it is 1 minus 10, 3. So write 1 minus 10, 3. So 2 minus 1, 1. 10 minus 3. So this minus becomes plus and it becomes 13. 5 minus 3. So it is 2. So here we get the value of x2 minus x1, y2 minus y1 and z2 minus z1. Just we have to put here. So x2 minus x1 is 1. So it is 1i. y2 minus y1 is equal to 13. So it is 13j. And z2 minus z1 is equal to 2. So it is 2k. The basic formula of position vector is x2 minus x1 I plus y2 minus y1 j plus z2 minus z1k. So this is the standard formula for the position vector. Just put the value of x2 minus x1, y2 minus y1 and z2 minus z1 in the equation. We have got the value of position vector and the force vector. We can find the moment of the force F about the point S. So it is cross product of position vector into force vector. So the format of the cross product is in the determinant form. Put the value of Rx, Ry, Rz, that is 1, 13 and 2. Then Fx, Fy, Fz are 7.96, minus 5.97 and minus 0.995. So here we will find out the cross product with the help of this determinant. So for the first point, suppose if you consider I, then cancel out first row and first column. So here it should be 13 into minus 0.995 minus 2 into minus 5.97. The next step is minus j. Start with minus sign and j. So cancel out the first row and the second column. So it should be 1 into minus 0.995 minus 2 into 7.96. So this will give you second term. And for the last term, we'll cancel out first row and the last column. So here it should be 1 into minus 5.97 minus 13 into 7.96. So this will give you the value of the moment about a point. So it is equal to minus 0.995 I plus 16.92 J minus 109.45 K. So in this way you can calculate the cross product for the given values. So this will go to step number 4. Step number 4 is finding the unit vector of this line. So for that, the line is unit vector is ST. So the final point is T, initial point is S. So write down T and S here. The coordinates of point T are 5 minus 8, 8. And coordinates of point S are 1 minus 10, 3. So write it here. Find out x2 minus x1. 5 minus 1, 4. Minus 8 minus 10. So minus minus becomes plus. So minus 8 plus 10, 2. 8 minus 3, 5. So we have calculated the value of x2 minus x1, y2 minus y1 and z2 minus z1. Then we will find out the square root of all those things. So it is a square plus b square plus c square, that is 4 square plus 2 square plus 5 square. Square root of that will be 6.708. Now to find out the components of this unit vector, we'll just divide this 4 by this value. So 4 divided by 6.708, so it is 0.596. EY will be 2 divided by 6.708, so the answer is 0.298. And last term is 5 divided by 6.708, the answer is 0.745. So after calculating Ex, Ey, Ez, write it in the vector form, that is 0.596i plus 0.298j plus 0.745k. So this is the unit vector for the given line. Now we'll find out the moment of the force about the line. In previous step, that is in step number 2, we have calculated the moment of this force about the point. Now we'll find out with respect to the line. For that, take the dot product of the moment with respect to the unit vector. So now the moment is already calculated. So moment of a force about a line is equal to moment of a force about a point, that is minus 0.995i plus 16.92j minus 109.45k dot the unit vector 0.596i plus 0.98j plus 0.745k. So here we get the dot product. You can use the calculator to find out the dot product, or you can multiply the terms related to the I, 0.995 into 0.596 plus the terms related to j get multiplied, that 16.92 into 0.298. So it is equal to this value plus the last term minus 109.45 into 0.745, and remove this ijk signs from it. Okay. So you have to just multiply the similar terms, like I term should be multiplied first, then plus the next term 16.92 into 0.298, at the end plus 109.45 minus into 0.745. So this will give you the value of the moment of a force about the line. So this is equal to minus 77.09 kilonewton meter. After getting this value, we'll just multiply this value with the unit vector. This will give you the moment of a force about a line in a vector format. So minus 77.09 into the unit vector, that is 0.596i plus 0.298j plus 0.745k. So the final value is minus 45.946i minus 22.973j minus 57.432k. We have just multiplied this value to every term present in this bracket. Okay. The unit for this is kilonewton meter. As it is a moment, it is a product of force into perpendicular distance. So it is kilonewton meter. So in this we can calculate the values very easily. First step will be converting the given force into a vector format. After converting this into a vector format, what we'll do, we'll find out the moment of that force about a point. So after calculation about the point, we'll find out the unit vector. Then after calculation of the unit vector, we'll find out the magnitude of the moment about a line. Then we'll find out the vector form of that moment. So by following these 5 steps, you can easily find the moment of a force about any line. Remember, the question will be asked based on the find the moment about a point or about the line. So these two types of question will be asked. Based on this, we have prepared these 2 videos. You can rewatch it. If you have any doubt, you can put it in the comment box. If you find this video helpful, you can like this video, you can share this video, and don't forget to subscribe our channel. Thank you very much.